is the start of section 8.2, Reflections and Translations of Exponential Functions. Start off, we're going to graph these two equations, y equals 3 to the x and y equals negative 3 to the x. If you want to think about this y equals negative 3 to the x, you can actually think about it as y equals negative quantity 3 to the x. Okay. That negative really isn't being applied to the 3, it's being applied to the 3 to the x power. The negative will just make that whole number negative. So first off, we've graphed y equals 3 to the x before. We know there's going to be a point at 0, 1, 1, 3, and 2, 9. We also know there's going to be points way down here. So if we were just to draw that nice curve, we get a line that's something looks something like that. And remember what these points were for y equals 3 to the x. Negative 2 becomes a 1/9. Negative 1 becomes a 1/3. 0 is a 1. 1 is 3. 2 is a 9. And so forth. Well, now let's see what happens with y equals negative 3 to the x. If we make our chart x and y, and we look at negative 2, that's really going to be negative 1/9, which is equal to negative 1/9. If you look at negative 1, it'd be negative 1/3, which is just negative 1/3. 0 is going to be a negative 1. 1 is going to be negative 3 to the first, which is just negative 3. 2 is going to be negative 9, which is going to be a negative 9. Okay? So now if we were to graph these points, negative 2, negative 1/9, negative 1, 1/3, 0, negative 1, 1, negative 3, and 2, negative 9. Those would be the points. Connect them. Draw a nice line. And in this case, and in both cases, the horizontal asymptotes are at y equals 0. Now, something that you should be realizing is hey, this function here, y equals negative 3 to the x here, just takes the graph of y equals 3 to the x and just reflects it over the x-axis. And that actually is going to be, in fact, true for all functions that have a negative out in front as an a value. So if we have y equals ab to the x is the general form of an exponential function, then like we saw in the example before, then we know y equals negative ab raised to the x will reflect y equals ab raised to the x across the x-axis. So again, if y equals ab to the x is the general form of an exponential function, then y equals negative ab to the x will reflect the general form y equals ab to the x across the x-axis. Right. So now let's consider the following example. Graph y equals 2 to the x and y equals 2 to the negative x. Notice the difference here. This one here, you have 2 raised to the x. In the second one, you have 2 raised to a negative x power. So let's explore what the graphs would look like of both of them. In the first case, we have y equals 2 to the x. Here's the table of values if you need them. We have negative 3, 1/8, negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, 2, 4, and 3, 8. So if we go ahead and graph them, there's what the graph of y equals 2 to the x would look like. Well, now let's see what happens with the negative exponent here. If we take negative 3, for example, for x, we have 2 to the negative power of negative 3. We have a negative and a negative here, so that just becomes a positive, and we get 2 to the third power, which is 8. Likewise, if we choose negative 2, we have 2 to the negative 2 power. Those negatives cancel and become a positive. And we're left with 2 squared, which is 4. So right now we have the points negative 3, 8, and negative 2, 4. Negative 1, same idea. You have a negative times a negative gives a positive power, which is 2 to the first, which is just 2. Obviously, we know if we put 0 in for our exponent, 2 to the 0th power will just automatically give us 1. If you have a 1, we get 2 to the negative 1 power, which is just 1/2. And likewise for 2 and 3, we get 2 to the negative 2 power, which is just 1/4. And 2 to the negative 3rd power, which is just 1/8. Okay. So if we go ahead and graph them, graph those points. We get this curve here. As x gets larger, the value of y gets smaller. So now what you're probably noticing is, well, hey, we had our function y equals 2 to the x, and then we just put a negative sign in front of the exponent x. And you're noticing that all that did was just flip the graph across the y-axis. And that's in fact true. If you put a negative in front of the exponent, that'll automatically flip the graph across the y-axis. Right. So we have our general function y equals ab to the x. So if y equals ab to the x is the general form of an exponential function, then y equals ab to the negative x power will cause y equals ab to the x to reflect across the y, y-axis. So again, if we have our general form y equals ab to the x as our exponential function, then y equals ab raised to the negative x will cause our general form y equals ab to the x to reflect across the y-axis. So one final example. we're asked to graph y equals quantity 2/3 to the x and both reflections. Well, if we think about it, if we have y equals 2/3 to the x, let's think about that in terms of our x's and our y's. Obviously, when x is 0, we're just going to have 1. X is 1, we're just going to get 2/3. 2, we're going to get 4/9. We're just going to keep decaying. Likewise, if we have a negative 1, we're going to get a positive 3/2. Negative 2, a positive 9/4, which is just over 2. If we have a negative 3, we're going to get positive 27/8, which is just above 3. And you can see the trend here. We can graph our nice curve. Now the question asks for both reflections. So let's start with the x-axis first. Remember to reflect across the x-axis. All we have to do is put a negative out in front of the parentheses here. So we get y equals negative 2/3 to the x. And all that's going to do, what's going to happen, is that's going to change our y values and make them all negative. So in doing so, we get negative 3, negative 27/8, negative 2, negative 9/4, negative 1, negative 3/2, 0, negative 1, 1, negative 1/2, negative 2/3, I mean, 2, negative 4/9, and so on. I will graph the x-axis reflection in green. So 0, negative 1. And we get these following points. And just connect them. And we get our nice curve. I know it's not exact, but it's pretty darn close to what we're going to get. Regraph that. So we graphed the function y equals 2/3 the x, and we took care of the reflection across the x-axis. So now we have to take care of the reflection across the y-axis. And to do that, all we have to do is just plug a negative in front of the exponent x, and then evaluate. So we use our table of values x's and y's. Let's start with the negative 3. We get 2/3 to the negative 3. That negative and negative becomes a positive, and we get 2/3 cubed, which is equal to 2 cubed over 3 cubed, which is 8/27. Likewise for negative 2, we get 2/3 to the negative 2, which just simplifies to 2 squared over 3 squared, which is 4/9. Negative 1, 2/3 to the negative 1 will just give you 2/3. 0 obviously will give you a 1. 1 will give you 2/3 to the negative 1, which is 3/2. 2 would give you a 9/4. And 3 would give you 27/8. So now if we were to graph it, we have 0, 1, 1, 3/2, 2, 9/4, 3, 27/28, which is right above 3 somewhere. If we go in the negative direction, we get 1, -1 2/3, -2 4/9, and -3 8/27. And now we can graph the nice curve associated with it. And that is the reflection of y equals 2/3 to the x across the y-axis.